USB Type-C connectors have become very popular because of their faster data transfer and faster charging options. We plug and unplug USB cables from our electronic gadgets many times daily. And when we touch or engage with the USB ports, it is possible and common to generate electrical transients such as electrostatic discharge and surge events, which is capable of damaging the circuits of the USB transceiver. Semtech SurgeSwitch TDS2211P is designed to address these threats effectively and to safeguard the V-bus pin of the USB Type-C connector. The crucial question now is how to ensure the circuit's resilience against surges during multiple transient situations. This is why Semtech ensures that surge switches undergo endurance tests, subjecting them to thousands of periodic surges of peak pulse current. TDS2211P is a single-line 22-volt surge switch. The clamping voltage of TDS2211P is 27.6 volts, and the maximum peak pulse current it can withstand is 40 amps. The endurance test subjects TDS2211P to 100,000 periodic surges of 40 amps each at room temperature. This scatter plot displays the peak pulse current plotted against the clamping voltage. Each data point represents a successful surge withstand event, demonstrating the device's ability to handle the 40 amp surge consistently while every point is below the clamping voltage level. These curves show the distribution of peak pulse current and the clamping voltage throughout the 100,000 surges. The peak pulse current and the clamping voltage remain within a narrow range. Now let us go to the applications lab to see how the endurance test is done.
So we have here a testing setup. What it's actually doing is recording the data for VPP or V-clamp rather versus IPP. And so up here in the scope, you can actually see each of the waveforms that are generated from each of the surges. And the blinking green light over there shows where it's being triggered by the surge that comes in from this surge device, surge machine, surge event. And here are the 2211 devices in series. And so up here, you have the bell-shaped curves you'd expect. It's a little bit of like, I don't know, what do you call it? Aliasing, I guess. And so the bell-shaped curves have these little dips and such. But anyway, they're correct shape. We would maybe worry about something if the bell-shaped curve was skewed, but it doesn't appear to be. So this device is actually working well and not changing with all the surges that are that it's enduring. So this setup right here is just the control program that controls power supply and the meter that I'm using to read the voltage that this surge circuit is being powered by, because that's constantly adjusted so that we want to try to keep the input power stable and not drifting at all. And it works pretty good with the setup because I think it's like 0.05% variation over the entire test. So it's constantly adjusted. So this graph right here is just indicating the strikes for V-clamp versus IPP, because this is what you kind of expect. It's just sort of a scatter plot, and each point indicates one strike. So that's what we're doing here.
With its popularity, USB Type-C ports are routinely exposed to fast rise time ESD strikes and surges. As such, it is essential that USB ports are well safeguarded from the dangers of the transient threats. Semtech makes sure via endurance test that their surge switches can protect the V-bus line of the USB Type-C port even after thousands of surge strikes, and thus they safeguard the power line of the USB connectors of popular electronics devices in real-world use. For more information, visit www.semtech.com. Thank you.